All right, so we're going to look at the graphs of a couple of these trig functions. We're matching the graph to one of these 5 equations over here. Okay. Let's see if this works. Yep, I can write on it. Awesome. So the first thing I notice on this is that it looks like a cosine function because it immediately starts falling. You know, at 0, whether it starts increasing or decreasing, that's usually a good tell for whether this thing is a cosine or a sine wave. So because it starts falling immediately, it looks like it's going to be one of these cosine functions. Okay. What else can I look for here? It has an amplitude of 2. So this right here, this line is called the midline. It's the line that kind of splits it in half. Now, if you measure from the midline up to the peak or down to the peak, or valley, I guess, whatever that distance is there, that's going to tell you your amplitude. Okay, and that's 2 units. So it looks like it should be A or B. Now, if you remember cosine of 2x down here, what that does is it vertically compresses the function. So it would be like it'd be a much tighter wave. It would look something like, oh, I don't know, something like that, where it would be a much tighter looking wave. Anyway, that's not what's going on here. It's not D. And then the last thing to look for is the shift, I guess. This thing has been shifted up, not down, right? If this thing would be shifted down, it would be, there would be more of it below the x-axis than there is above it. So since this thing is mostly above the x-axis here, this thing has definitely been shifted up, which leads me to believe that the answer is going to be B. Now, the other way that you can tell this type of thing, besides memorizing all those vertical stretches and compression rules, those just take time, is to pick out a test point. Okay, so if I look here at my y-intercept, that is 0, 3. So what that means is that if I plug in 0 for x, I should expect to get a 3 back. Okay, and so that's usually the way I would do these whenever I was in school. I would plug in 0 for x on all of the functions and then see if I get a 3 back. Like if you try out option A, 2 cosine of 0 minus 1. Well, cosine of 0 is 1. You could use a calculator if you had to. 2 times that would be 2. And then, of course, 2 minus 1 is not equal to 3. Okay, so it doesn't work out. But if you were to try that with a correct answer, all right, this part right here would give you a 2, and then 2 plus 1 would give you the 3, right? Yeah, let's try it for pi as well, okay? 2 cosine of pi plus 1. So cosine of pi is -1, and then you're doing -1 times 2. So that's -2 plus 1, and that comes out to -1. And that is the value of the function at pi. And it works all over the place. You know, right here, if you try plugging in pi over 2, you'll see that you get 1 back as your answer. All right, let's clear this out. We'll do one more. Okay, which trig function is graphed below? All right, so this one, starting at 0 here, this function immediately starts increasing. So that leads me to believe that it is a sine function. Okay. What else do we know? How else can we tell? Okay, this thing has definitely been shifted up from the normal. You know, normal sine functions look like that, where it goes above and below the x-axis. So I know that it's been shifted up by 1 unit at least, so it can't be option B. I guess the other thing is, like, it's not the normal sine function, because the normal sine function takes 2 pi units to start repeating. This thing is repeating much faster than that. All right, it's been horizontally compressed. So it's option C. Okay. If you want to do the thing where you plug in a point, say you plug in 0 for the x. Sine of 0, all right, pretend you plug in a 0 there. Sine of 0 is 0, and then 0 plus 1 is 1. All right, pretend you plug in a pi over 2. That would be sine of 3 times pi over 2, otherwise known as 3 pi over 2, plus 1. Sine of 3 pi over 2 is this spot, all right? 3 pi over 2 is 270, and that's equal to negative 1. So what you wind up with is negative 1 plus 1, which is equal to 0, and that's the value of that function at pi over 2. Okay. I guess another one you could use is way over there. That would be a little bit harder to think about, wouldn't it? Because that would be sine of 9 pi over 2 plus 1. So I guess you'd have to know what sine of 9 pi over 2 is. I'm guessing it's equal to 1. Yeah. Sine of 9 pi over 2 is probably equal to 1. And then you have 1 plus 1 is equal to 2. And that's why it's a 2.